here who doesn't know him. He's the R&D coordinator at LACNIC, and he's going to talk about IPv6 mostly networks, the link that we lacked, the missing link. Good morning. Thank you for the presentation, Ali. Well, as my namesake was saying, we're going to talk about IPv6 mostly networks. I'm very happy to present this. I want to thank FTL for having accepted this paper. And I'm very happy because this is a topic that is already several years old in our ecosystem, and unfortunately, we haven't dealt with it at LACNIC. So sooner, better late than never. So, if you look at this, as Google did, this is more processed, but we have that the mostly IPv6 networks are described. This is a relatively new concept with an uptake that has been very fast, and it covers the link between the IPv6 only networks and the dual stack networks. Of course, the aim, there are two goals that are marvelous. One is to going to the IPv6 space, and the other is to try to make up for the shortage of IPv4 addresses. So this is in section 1.2 of RFC 8925. This says that the IPv6 mostly networks provide NAT64 services, possibly DNS64. So we have to pay attention to each word. This is a very important slide. So IPv6 mostly networks have provide NAT64 services, potentially with the DNS64. We all know that NAT64 and DNS64 are two transition mechanisms that differ, but quite often they go hand in hand, as well as IPv4 connectivity. So the IPv6 mostly networks also offer IPv4 connectivity, which is not the case of the IPv6 only networks. It makes it possible to have IPv6 only hosts. There's the dual stacks, the IPv6 mostly network, and also have dual stacks, and of course everything in the same segment. That is, we can see that these IPv6 only networks have all the toys: IPv6 only in the network, IPv4 only, dual stack, well, you name it, plus DNS64 plus NAT64. So we've put all that together. Operators can gradually disable IPv4 in both, and we're going to describe that in detail. So let's go through something that is very important, and so well, this is what I need to understand to go to IPv6 mostly. That is the DHCP in the IPv4 world. There's a handshaking, exchanging messages in 4 steps. The first message is called discovery. Some put it as discover. Basically, it's when the client sends a broadcast message identifying the DHCP server. So they may also identify a DHCP relay, but the server is the most usual. So discovery, the client looks for the DHCP server that receives it, and then they send an answer, an offer, providing the resources the client is requesting.
The request, the client tells the server, thank you for your offer. I would like to have it. Give me those resources. And in the acknowledge is when the server says, okay, you can keep the resources I offered earlier. And quite obviously, it's going to block that resource from the IP address block they have to deliver in the network. This process is called DORA. In red, you have the explanation of the acronym. So having explained that, there is something that you need to understand. These are the DHCP options. I think many of you here are familiar with that. This is like additional information that is contained in the DHCP message. I personally think these are not optional, but this is what you read in the books. So basically, when you see in the communities, what they do in BGP is to provide additional information. DHCP options are more or less the same. It's as if they were assistants sending a packet in an airport, and I put handle with care, priority, this side up. This is more or less the same. And I say this because Alejandro explained so much regarding HTTP, but in the IPv4 world, because the IPv6 mostly networks are closely linked to this concept now. In the RFC 8925 that I mentioned initially, the title is IPv6 only preferred options for DHCP version 4. This document defines option 108 that indicates from the client to the server, I am a client in your network and I can work with IPv6 only. So I don't need IPv4 addressing. If you read the slide, it states that the host supports an IPv6 only mode and is willing to forego obtaining an IPv4 address. And this is the magic. The client tells the server, I can operate in your network with IPv6 only. Tell me, server, do we agree? And if the network has all the toys that I wanted, DSM4 and so on, then we're ready to go. So let's speed up a bit. We have the client on the left side and the server on the right. We send the discover message with a whole set of parameters that are being requested, and in this case is to do the gateway and the DNS. And you will note on the right side at the top in orange, it says 108. That is the assigned number, the option. The server sends the discover message, and the server says, well, these are the resources you requested, and you know, I can do 108. And it states 30 minutes. These 30 minutes mean for how much time the client will pay IPv4 until he does this process. 30 minutes might seem a lot, might seem a little, you can adjust that. But basically that is what would be happening. Very simple. Now let us go at the details. Let us compare the negotiation of DHCP with option 108 and without 108. At the top left, in the first capture of Wireshark, we have, without 108, the entire DORA process: discover, offer, request, and acknowledge. Below, it's with the option 108. And I like to say that this is like a short circuit. It takes the HTTP handshaking, it does the discover, and then the offer. Now you will note that the client then doesn't continue with the handshaking process. So the DHCP server will not block the IPv4 address, and then saving a large amount of resources. Here we have two examples, one at the top and one on the right. At the top, we have an example of the configuration of DHCP. Here, with this specific vendor, we see it's written in hexadecimal, but that doesn't really matter. It's in the green rectangle. Option 108, hexadecimal type, and the data. This is equivalent to 300. This is 300 seconds. And we see the Wireshark capture that is equal to the option 108. It's very clear. It's IPv6 only preferred, length 4, and it has IPv6 only preferred wait time, 5 minutes, which is 300 seconds. So to sum up, you might say, well, Alejandro, that's so interesting. But I might say, how can I go to IPv6 mostly? But this is mandatory. What do we require as mandatory things? You have to have a network that has NAT 6.4 and DNS 6.4. You need to configure the DHCP v4 server with option 108 optionally, so that everything works perfectly well. The clients, and on Tuesday, Alejandro de Gidio made a presentation on 464X-LAT, and he also mentioned CLAT, and also Jordi Pallet, together whom they had written a draft at the IETF. So CLAT is a software that's installed on the customer's side. In many cases, it comes by default included. This delivers an IPv4 socket. So optionally, implementation are RVC 8781, which discovers the NAT 6.4 prefix in the router advertising message. Obviously, if we have the NAT 6.4 network and DNS 6.4 using the well-known prefix, that part would not be necessary. But if we can do it, that is optional. And to close, I think this is my last slide, the advantages of IPv6 mostly network. There are many more advantages. Without doubt, there is significant saving in IPv4 addresses, about 2/3 of the devices. Imagine this network where we are now in this event will be serving 2/3 of the IPv4 addresses that the DHCP server is assigning. And behind that, assuming that there is NAT, imagine this would be a university campus. This is a deployment that is being done extensively in enterprises and organizations. And in the university Wi-Fi, if we have NAT behind it, there are many IPv6 clients. So we're saving a lot of processing and memory in the devices with NAT. And of course, we know that dual stack is ultimately far more complicated. So thanks to IPv6 only. So this is basically what I wanted to share with you. I know Jordi is from Spain, but I'm going to put my headset on. Hello. Can you hear me? Congratulations, Alejandro. I'm going to speak in Portuguese. Are you aware of the operational systems that already work based on RFC 8295? And if the ISPs and the internet service providers are aware that they can do this configuration with option 108 in their devices? Thank you, Henry, for your question. Let me tell you the answer. Regarding Android, the latest version and the previous version already have incorporated that for 5 years already. I wanted to include that in the slides, and Mac has also been doing this for quite a long time. iPhone is going to work perfectly well with option 108. And once Jordi says something, I hope he supports me. And if the providers are aware of this, I would like to speak on behalf of the providers, but this talk is so that those who didn't know about this now know it. Of course, providers and so on could be many enterprises and companies in your networks. Thank you, Henry. Thank you.
Ahora. Okay. Jordi Palet.
I'm Jordi Palet. To add on to the question and the answer, in fact, quite obviously, the providers should be aware of this, but this hasn't been thought for the ISPs. It has been considered for corporate networks, private and domestic networks, government networks, ministries, and so on. Universities, of course. So any type of network that we can say are local networks or campuses. Now, the only important operational system that does not support this is Windows. But Microsoft has committed itself, and in fact, it is very likely that we'll be able to inaugurate this at the next IETF meeting in July this year. Although this has been standardized for a long time now and massive testing has been done, I can tell you that one of the persons who work in the standardization of this works for Google. And you can imagine that they have tested this in Google's corporate network. Imagine the size it has. So it's a very big scale. They have detected problems. They have solved these problems. And following that, standardization has been completed. At the latest IETF back in March in Bangkok, we had an SSID in the wireless for testing purposes. Many of us joined it to test this out in a environment of engineering, as is a case of IETF. It worked perfectly well. There was an issue the very first day, but it continued working well. At the next IETF that will be held in Madrid in July this year, this will be by default. So all the users of the network will be in the IPv6 mostly environment. If something does not work, you can change to another SSID. But that is the idea. And quite obviously, we expect to continue with IPv6 mostly by default from then on. And the important point, and this is something that Alejandro mentioned in his last slide, is that managing a dual stack network has its additional complexities, and ultimately this is an OPEX that is quite significant. If there are more and more devices that work with IPv6 only, why are we going to be delivering IPv4 addresses? That's more or less the concept. Thank you for your comment, Jordi, regarding Microsoft's situation. A very famous podcast called Packet Pusher. They interviewed someone from Microsoft who specifically spoke about the deployment of 108 and in Windows environments. If you update Windows, it's likely to be there. One last question, I think. What would name? Right, is for my question has to do with what would you recommend to the smaller ISPs and medium-sized ISPs who already have an IPv4 addresses and want to implement IPv6. What do you recommend them to do? Thank you, Rainer. As Jordi was saying, this is more addressed at the corporate segment. This is a link that was missing in the corporate world, where the IPv6 deployment hasn't gone at the expected speed. What would I recommend to a small ISP? I would say speak to those organizations that are requesting more resources. And as a small ISP or even larger ISPs, well, this exists. Please check this out and try to promote this in your network. Thank you.